And let's also zoom in on our characters. So we're going to want to go to 5D perspective camera, and we're going to want to use the close-up camera for this level. So in our standard player, we want to use the 5D close-up player for this thing. The other question is, did we actually already solve this by switching to masked objects? Yeah, so we're trying to fix stuff like that. Yeah, so this is what z-fighting is right here. Basically, these objects are right on top of each other, and we need to fix that. So right now for our settings, our sorting axis is along the x-axis. And since we switched to a perspective camera, it's actually fixed a lot of the stuff when we're using a masked sprite. It's actually using the pixel depth and all this other stuff as well. So, translucency, it can't really do that. So the issue is z-fighting. We need to solve it for translucent objects. So there are the cases of translucent objects, and we also want to solve it for masked objects. So basically the fact is we've got the x-axis and it's really just these paper sprite or paper flipbook components. Yeah, they're paper sprite components. So it's these sorts of things, and what we need to do is we need to move all these things just a little bit. So, like, we want to have a rule basically that if objects are next to each other or aligned or something like that, then we need to, in the x-axis, we need to separate them. So since we're dealing with a non-orthographic projection now, like it's a perspective camera, that means that, well, we can't just have a sorting layer thing and like slot stuff in. We actually need to do this in an analog fashion. So let's see, what are some options? We need to each frame iterate through all objects in the scene, move those up, move individual components relative to their parents in the x-axis so as to not collide with other components. So if we're going to do this, we basically need to create some sort of system where we know if things are too close to each other. So like if an object is at 0, if we have like 4 objects and they're all at 0, so 4 objects all at 0 x, like what we could do is we could say, okay, well, one of them is going to be at 0.1, one's going to be at 0.2, one's going to be at 0.3, one's going to be at 0.4. The issue is, like, we add another object and it's at 0. Where do we put it? Do we put it here? Just like, so it would draw behind the thing? And is it important, like, is it important that everything is completely consistent and all that? So like, if we're putting stuff on 0, is it important that a certain object always goes in front of a certain other object? Like if we have 2 enemies, they're both at 0 and they get spawned in at the same time, is it important, and in like the exact same place, and let's say one's like a really tall dude, one's a really short dude, and if they both get spawned in on the same frame, and maybe the order doesn't always get changed, or maybe the order matters, maybe we have it so that it's basically a begin play on the paper sprite and the other components. It checks the X value. So the question is also, should we remember the original X offset for the component? Because if we remember the original X offset, then what we can do is we can basically resort at any time. So if we had 4 objects and they're all at 0 and we end up putting them at these other positions, if we add another object, it would just be, okay, well, you're going to be at 0.5. And if we resorted every single time, it would always be consistent. We could always like follow some rules and have it. So I think it'd be best to have like a memory of the actual object's offset, and then because we're going to need to actually move it in the world. So be like, go through everything in the entire scene that's visible. So go through all objects in scene that are visible. Bucket up objects into a map based on X, and bucket size should be something like 0.01 or something like that. And then basically, well, we could do like, if it's 0.001, yeah, if it's 0.1 and step size is 0.001, so that would mean like we can sort up to 100 objects in the same sublayer. Alright, Karakan, you have a good one. See you later. I'll probably be joining in on Adam's stream a little bit when he gets... I don't know what he's doing. Who knows? I'll at least be an audience member for a little bit. So I will see you then. So if we make like our bucket size of like 0.01, basically we bucket up all the objects based on their actual real x-axis position. The bucket size should be 0.01 and the step size should be like something like this. So basically equals, we can have 100 overlapping objects without artifacts. We need to remember the offsets that we apply. And basically what we'd want to do is we would want to take we'd sort based on certain numbers of rules. Like we'd want to sort based on objects with lower y values get bucketed first, then resolve conflicts based on actor ID, with lower actor ID gets drawn in front of higher actor ID, or the opposite. Because actor IDs are unique while the actor is alive. So the question is, what happens if we move an object? We need to run this sort. This sort needs to run after everything in the scene moves. The only thing to move should be the primitive component being drawn. So not the parent actor. So what sort of implications does this have? If an object, how do we store we have to actually set their position. So if some component touches the primitive component's position, we no longer have a memory of what it was. So if we wanted to move our subcomponent based on its x-axis, we would have some major problems. When do we actually use subcomponents? Well, we use it in blueprints right now to, like with our log, we've got that sort of thing going on, like right here, where we've got two masked objects, like so. So these have initial offsets. The question would be, do we have any objects which that are like this that we will be moving relative to the parent at runtime, such as, and these are 2D things, so like if we've got something we're moving in the x-axis, we'd have to have like set basically you'd have to like set a new offset sort of thing in there and reinsert this thing. So I mean, we could add to the paper sprite and paper flipbook components a function to move them in the x-axis or remember their offsets, and that's where we could actually store this information. And I could probably also just say like, well, if you change the x offset of something, it would basically be if it moved from what we expected. I mean, we could have like a pre-pass on these things. Like we could do a pre-update where we look at all the objects in a post-update and see like if they moved. So we'd have like we would have an expected X position, and if it moved too much, then we would basically say like, okay, well, if that moved, if that's different, then this object got moved and we should resort it. I mean, we're going to resort it anyway. The question should be, should we actually handle this properly, or should we just deal with it? I think if we just have a reset function for sorting these things, it's like just call it every frame and it'll get resorted. So that would probably work just fine. So the other question is, should we have the paper sprite components actually have its offset value stored in and of itself, or should we have a system that stores the offsets associated with the components. If we had it stored inside of the components themselves, then we don't have to worry about things going out of scope. They're just there or not there. So let's see if the paper sprite and paper flipbook components have anything in common that we can use as a root to actually store this stuff. So the paper sprite component's a umesh. And the paper flipbook component is a umesh. So they both come from umesh, so I could basically have like a since they're both coming from the same class, I can just make like a little class in between them. Alright, so I think the offset data lives on the component. We change the sprite / paper flipbook to be sortable components, like sortable mesh component, which extends from mesh component. And we add a sort objects method to the graphics manager, which runs post physics updates. And all that. And the other thing we could do is we could, instead of doing this based off of the... Yeah, alright, this is going to have to be based off of the X. Yeah, that makes sense. So how do we go through all the objects in the scene with these components? I mean, we could add like a register and sort of thing. Yeah, the question becomes, how do we keep track of all sortable mesh components? We could, on begin play / end play, add or remove them from a registry. And how do we register the thing that's gonna do the registrations? So we need to have a global registry callback. We need a delegate, which is bound, which can be bound. Yeah, I guess a delegate would be just fine, like a static delegate for the class, which we can bind to. Because then basically the graphics manager thing can just bind to that, and then it gets mention of every single one of these things in the scene, and then we've just got the list, and the delegate system should just work. So we have a static delegate for registers /unregister for our objects. We have the graphics manager on startup bind to receive calls. Let's see, how should we bucket everything up? Is there any clever way to subdivide infinite space into 0.01? Probably not. So we'd probably want like a T-map of float to T-array of use sortable mesh component. And basically iterate through. Hello, Synachron. We're trying to design our system that will basically bucket up our objects that are too close to each other. Like, if you see this right here, that flickering, that's a bunch of Z fighting, because the objects are right on top of each other. So in the pixel shader, you lose precision in the depth buffer, and you have absolutely no idea which object should be drawing on top, because mathematically they're identical calculations. So so we need to make that always consistently draw, and how we're going to do that is we're going to move the objects a small, tiny little bit. And it's only the 2D objects, but it's on a component level, not on an actor level. So stuff like that. Internet is trolling you? Yeah, that will happen. So I'd like to iterate through only the objects that are actually visible. I mean, there are some optimizations for this thing. So do not resort buckets if no object has moved in that bucket. And it would be no object joins that bucket. And we would have to have previous knowledge for that. Like, okay, how would we know if a new object was in the bucket? Well, we could have like object IDs and all sorts of other crap in there and check against them. We only want to iterate over objects which are on screen or close to on screen. We want to trivially reject all objects way outside of our area. Do not sort things way far away. Because this is going to be every component that has like every paper sprite and every paper flipbook is going to have this thing on them. So if we have, if we have a giant, 3 kilometer long level, we don't want to iterate through every frickin' bramble on the entire world. And so the other thing that we don't want is like if we've got, this is a good example. There's some pretty big issues here where, like, if we've got 100 objects that we could place inside of something that big, well, if we put every like bush on 0, 0, and there's like 10,000 bushes, then like we're screwed for sorting. But of course, the thing is the bushes are going to be spread out. Like if this is the track, we're going to have a whole bunch of stuff that's going to be along the track. So we want our buckets to actually, they're going to have to be a little bit smarter than the average bear. So, pretty much what we'd want to do is like we just want to take everything that's, within our camera's viewport. Kind of like that. So if we went through like every object that's within this, expanded frustum, and then we resorted based on that, that's pretty much what we'd want. And it'd basically be like you can't have 100 objects in view that are all on the same thing. We could try some sorts of stuff like, the issue would be if there's like some really big object which gets on screen. And we also want to trivially reject things. So like certain objects we don't want to do any x-axis stuff. So like do not sort any background objects. Like do not sort any foreground objects. So maybe we have like background objects or foreground objects that are placed in the level to begin with that don't need to be sorted. So we just throw them out there. So if we already have all these objects registered, then we can kind of segment them ourselves based on based on their location. I mean, we could iterate over everything. You know, we could do like some sort of insertion sort of thing, have our own sort of organization. You know, we could organize everything based on the y-axis. Like if we've got a t-array of usortable mesh component, and basically in memory it's, you know, sorted based on y-axis, then you basically go, okay, well, you know, left and right, blah. I mean, we wouldn't want a t-array, we'd want a t-list of a kind of a sorted t-list of mesh components. And it's more of like a T tree. So it's like a sorted balanced tree of stuff sorted along the y-axis, and that's how we would figure out which objects are available. But that's not really what we want. Well, let's see if there's anything for like if somebody's already written something up on like, oh, just use this system. I mean, is there simpler? No, we need to actually move the real world location of these objects for them not to z-fight. And it doesn't look like there's anything that slots in perfectly anyway. So let's keep thinking. So I need a data structure that's going to have these things nicely sorted, and if any of these objects move, that data structure needs to be recreated. So it's basically like get all components of type nearby Unreal. Like, I don't know if there's already some sort of sorted actor get component stuff. So let's take a look at these objects. Yeah, like we could get the object types of everything here. So if we made like static objects that can't be moved in the game, or movable objects like that, I'm trying to think, what would be the right way to do this? Because like I'd rather not iterate through every single component that we've got every frame. Because if we have, you know, a whole hell of a lot of bushes and crap like that that are set up here, then we're going to have a problem. I mean, the other sort of thing is we could have a, you know, a grid of objects, and we just index by grid squares, and we have grid squares be able to go on forever, and we use, you know, a map of grid coordinates, you know, so it's like a t-map of x to a t-map of y to a t set of used sortable mesh components. And like x/y are coordinates like 100 by 100 squares. And you'd basically add for an object, you'd add to all applicable squares. Then at the start of your sort, you get the number of sortable objects. You'd have a T set of all sortable mesh components that are visible, and you'd basically take the four corners of your frustum and you'd iterate through all those grid squares that you can see, and add to your sort list. Well, I mean, if we just did like this passive big sort thing, then I guess that would be one way to do it. The other way we could do it is if you always had to call sort after you moved yourself. So only actors that are actually moving are sorting, or like everything gets sorted to begin with, and then when you move, you have to call resort, and resort figures out where you're supposed to be. It just touches the objects that are close to you. Kind of like we do resort grid square. Hmm. So the question would be, how would you know if something moved between grid squares? So, like, if any of these actors moved, you'd have to go through every single actor and every single component and see if their transforms have changed. So for every movable object, you have to do it. I mean, you could call resort on every object. Um, I mean, we could have a tick on the actual sortable component, and we could have them actually check if they've moved since last frame. And we could resort the object, and the this tick could be turned on and off. So if you had a static object like a bush that doesn't move, we would just sort it once on begin play, and it'd be like, oh, I'm not an actual moving actor, and all that, so not a problem. Alright, so we need a couple stats to keep track of. We're going to need number of objects sorted each frame. We're going to need number of So yeah, it looks like we're going to do this like grid-based map sort of thing. We're only going to be sorting stuff that matters. Like we're going to sort stuff. We're not going to be sorting the background objects, I don't think. I mean, we could sort background objects. That wouldn't be the worst thing in the world. They'd kind of be sorted to begin with. And if we're not moving stuff around, it shouldn't actually do much to our sort. So I'm getting getting closer. I'm still just trying to reason through how exactly we need to have this work, and also scale to having lots and lots and lots of objects on a very large level. So we're looking at, we're gonna have everything in basically a big container that's based up by grid squares. So we're only grabbing the certain grid squares that we can actually see. Now the question is the optimizations for those buckets, which are the x-axis buckets. We are going to only resort those if something joins that bucket. Now the question is there a way to trivially not have to sort that bucket again? If everything was already sorted once, it's going to be aligned to one of the things. We could basically, like, when we iterate through all these objects, you know, we could use an integer map or something else like that we slot things into, and if they're already sorted, then they'll go into a pigeonhole. And if we want to be consistent though, regardless of what's going on, so we can't optimize too much there, because it's basically we just have to resort if anything gets added. So if we like move to the left and right on our screen and we're looking, we're always going to be resorting a lot of objects that we're seeing, because objects will be popping in from these off-screen grid squares. And depending upon the size of the grid square, depends upon when we have to resort static objects. So if the grid squares were bigger, we'd be sorting less, but there'd be more stuff to sort when we do sort. Well, we're never going to have more than like 10,000 objects on the screen, regardless, so iterating through 10,000 objects really is nothing to modern computers. So as long as we're not, you know, doing an n-squared algorithm, we'll be fine. Especially because we're already bucketing stuff into, you know, small things. We're not going to have a very big n for our n-squared. Unreal does handle occlusion, but we're talking about things that are exactly on top of each other. So, because it's a 2D world, you know, it's a little different. Because if this was a 3D world, right, it's just like, well, you have your physics engine to prevent boxes from being right on top of each other, but this is a 2D world where we want, you know, fat sacks to be able to run past each other and not collide and look proper, right? And that's not something that happens in a 3D world. You know, you don't have a Jeep that just drives right through a tank. You know, like it's just not something you do. So it's not occlusion. It's more sorting. It's and depth sorting won't work because they're at the same depth. So to give you that visual again, it's this fighting right here. We're going to solve that by doing things like moving their objects out and doing that efficiently. And you know, there's a lot of ways to do it. So I'm trying to come up with a system that kind of handles it all for me, so I don't have to worry about anything. The other thing would be to just, when you spawn an object in, it gets a slot, and that's just it occupies that slot forever. The only problem is how do you hand out slots, and how many slots do we have? Because like if you've got a track that's got 10,000 or 100,000 objects on it, and they're all positioned, they all want to be positioned at exactly 0x. Well, you could iterate through all the objects, find their widths and heights and all that stuff, and see if they conflict. Well, I mean, that would be one of the things, right? Is if do we have enough mathematical space in our numbers, such as, you know, you could just add a small number to it and just not worry about it again. And this is also a place where maybe it wouldn't really matter at all if you just like, you could just fake the whole goddamn thing just by like adding a random offset when you spawn the object in and just being like, well, it'll probably be right. Fuck it, you know? And randomly everything will probably be actually just fine and you never run into any issues whatsoever. And if you base that random number off of like the spawn ID of one object or something, you could actually get it to be pretty consistent. So it's more of I'm trying to come up with a system that isn't just going to be a giant memory suck, and will guarantee consistency and all that sort of stuff. And also be better than just like a hack solution. Yeah, you know, like just have a little epsilon that you throw on every object, and it starts off at like, you know, 0.00001 or, you know, something like that, and then you got like, okay, you know, if we put this on its side here, right, we've got, you know, we've got 10 million objects, and when we get to the 10 millionth object, we just, you know, roll it back over to 0. And right, like, so your 10 millionth object or whatever has, you know, like 9999999 as its offset, and then, you know, within your space it should work, right? Whatever. And like solutions like that are okay, like they'll probably work, but you know, when they don't work, you know, that's how you get inconsistencies. So it'd be nice if, you know, we guaranteed everything always looks properly. And the other thing that would, and it is good that we're actually right on the track there from like where we have all our objects pretty much from 400 to negative 400, because floating point values are much more accurate the closer they are to 0. So it's not like we've got a case where we run off into the weeds and then all of a sudden our depth sorting goes to absolute garbage town because, you know, we're not at the origin of the universe.